Now, I'm going to start some organic chemistry with you. You have a little of it done already, but it'll take quite a bit of time to cover all the organic chemistry. That will be worth 3 questions on a Leaving Cert paper, and there's no way of anything like that done yet. So I'm only going to dip into the introductory part of it and make sure that has been reinforced and that you're in a position to handle the few mandatory experiments that are going to arise in this particular section. Now, that's the entire syllabus for you. I'm just showing it to you for a start. Okay, there's an early part there where you need to be able to describe the name of a compound and be able to draw compounds from the name, so the vocabulary would be relating to that. There is a systematic naming system called the IUPAC, International Union of Pure and Applied Chemists naming system, and it's an international naming system so that we're all talking about the same compounds. That's the part that we're going to do. We're going to do numbers 4 and number 5, and you should all have this set of notes now. It has been attached to this particular video. There are a total of 6 pages in it, 3 for this particular session, and there'll be 3 for the subsequent videos that will follow this. So you've a total of 6 of these, 2 3s, okay? Organic chemistry written on the top of each of them. So will you make sure you have them, please? If you haven't, now pause your video, go and print these notes before you start continuing with this video, okay? That's very, very important that you do that. All right. Now, I'm going to start with you by making reference to a few things here that we need to be clear on. Just basically some of the terms that will arise in this section and how you might deal with them. There won't really be any issues here other than just make sure that you're able to identify the question you're asked more than anything else. Now, there are families of compounds in organic chemistry that you're expected to know about. And for your sake, for the moment, you only need the first 3, okay? Only the first 3. You won't need anything other than the first 3, so don't worry about them. But the first 3 are called hydrocarbons. And they're called hydrocarbons, of course, because they only have carbon and hydrogen in them. Okay, and be very careful with that. Okay, now I've drawn skeletons here for you for the moment, just to show you what's involved. Alkanes, alkenes, and alkynes. Now, guys, will you be very careful with your writing, please? Okay, this kind of stuff. Okay, the examiner will not accept any ambiguity where you might be suggesting, perhaps, as you're doing this, that it could be either. Now, please don't do this. You won't get the marks. That letter in there needs to be very clear. Is it an A, is it an E, or is it a Y? Alkane, alkene, or alkyne. Okay? Now, please be aware of them. They're hydrocarbons because they've only carbon and hydrogen. Now, the golden rule in organic chemistry is that carbon always has 4 bonds. Always 4 bonds. No matter what compound it's in, it has 4 bonds. Okay, and you need to recognize then that each family or homologous series has some feature to the molecule that allows you to identify it as belonging to that family. And I'm putting it to you now that you must be careful. If it's an alkane, then it is all single bonds. Okay, if it's an alkene, there is 1 double bond in it. And if it's an alkyne, there's 1 triple bond in it. And I think that's very important then that you recognize that, okay? You won't have any difficulty with this now because it's very routine, it's repetitive, and you'll find yourself building up speed in this very quickly once you get certain things done. We won't worry about the rest for the moment. An alcohol has an OH stuck at the end of it. An aldehyde has a CHO stuck at the end of it. A ketone has a CO in the middle of the molecule. A carboxylic acid, as in vinegar, has a COOH at the end of it. And the ester is a derivative of the acid then. Now, that's the entire course, and I respect that totally, that you won't be doing anything like that this year. The first 3 in particular are very, very important for you, and we're going to give most of our time to them. They're called the hydrocarbons because they have only carbon and hydrogen in them. Is that all right? And we have to work our way through that to make sure that that's okay. Now, I'm going to look at a few terms here for a moment just to make sure everybody's okay with that. Okay? A few terms. Now, don't worry about them. Just take it, will you please, that you just need to get sharper on these in terms of what it would actually entail. A homologous series refers to a family of similar compounds. They have similar chemical properties, and the chain just gets longer, a carbon at a time. First member has 1 carbon, the second has 2 carbon, the third has 3 carbon, etc. The general formula is a way of recognizing which family it is. And I'll deal with that in a moment now because it's important you'd be able to do that. The functional group is some group of atoms within the molecule that determines the chemistry of that particular homologous series. The terms saturated and unsaturated you'll need to know. If something is saturated, it has all single bonds. If something is unsaturated, it has one double bond or one triple bond for leaving cert anyway. Okay, there could be more later, but not for leaving cert, okay? So it'll have a double or triple bond if it's unsaturated. The term aliphatic refers to a long chain, an open chain, whereas the term aromatic means it's made up of benzene rings. Now, in the next video, I'll talk a bit more about that, but you just need to realize aromatic has a benzene ring in it, and it has a particular set of features all its own. And the concept of isomers is very important. These are molecules with the same molecular formula, but different structural formulas. We have to be careful with them, that we would be aware of them, what's happening. Now, I suppose I'm more concerned about the naming at the moment, so let's look at the IUPAC naming system, right? It's very important that everybody would have a sense of being able to read the paper, is what I'm suggesting to you now. If there's only one carbon, then the name will start with meth. If there's two carbons, the name starts with eth, prop for 3 and but for 4. And I could confidently say to you, mainly those 4 will come up in leaving cert, unless it's a special molecule. Okay, we have occasion where octane comes up, as in petrol. So obviously oct is 8. Now you probably know the prefix is pentagon, would be a 5-sided figure. So pentane would have 5 carbons, hexane 6, heptane 7, and octane 8. You won't need any outside that, you're fine. Okay, if it got worse than that, well, they'd have to give it to you, let's put it that way. And just to know that at the beginning of the name, the prefix will tell you how many carbons you have, and you'll work from there then. Now, I just need you to have that so that we can get going on this, because we're going to start talking about hydrocarbons immediately. And I'm going to start now with alkanes, just to get the idea of alkane. Alkanes are basically hydrocarbons, okay, with all single bonds. And you won't have any issues with that. We can deal with them whatever way we want. There's methane, ethane, propane, butane, and pentane. Now, will you let me just construct them for you for a moment? Sorry, now I need to construct them for you so that you're in a position to, to be able to build them from nothing. That is all very fine to be looking at them, but you have to construct them, okay? Meth has 1 and has 4 carbons, 1, 2, 3, 4. Now, I call that a skeleton. And a skeleton means that the hydrogens are missing. You put them in last. Under no circumstances would you leave that on an exam paper. But you must make sure that every carbon has 4 bonds first. That's very important. If you have 2 carbons in a chain, they must have 4 bonds. They have 1 already. 2, 3, 4. 2, 3, 4. Okay, the next one is prop. So there's 3 carbons. 1, 2, 3. Now that one has 1 bond already. It needs 3 more. That one has 2 bonds already, it needs 2 more. And that one has 1 bond, it needs 3 more. And now, of course, finally, you put in the H's. Now, you see, when you look at these in text, you see the final molecule. Okay, you see all of this written for you already. And you're not thinking logically then about how do I go about this? I've told you, you build up the skeleton, make sure your valencies are right, that you have the right number of bonds, and finally, and lastly, always finally, put in the H's. And that's what will happen, okay? And there's no distraction then. The next one is but. But is 4 carbons. And they must all have 4 bonds. That needs 3. That needs 2. That needs 2. And that needs 3. And that's butane. And pent would be 5, then you can see there, and that's exactly how you go about that. There'd be no issue with that at all. Now, are you okay with that? Now, they are alkanes, right? And we would have to refer to them at various stages along the way for names. And I'm going to go on to the next section now. If you're dealing with alkenes, then you have to have 1 double bond in each of them. You have to have a double bond in the molecule. Now, okay? And the first member is eth, because you can't have a double bond between 2 carbons without having 2 carbons. So the first one is ethene. So here we go. I'll rule them off now. They're the alkanes. Okay? Alkanes. A-N-E-S. Watch that letter now, please. Alkanes. These are alkenes now. Okay? A double bond there. That's what you write first in the exam now for ethene. Now every carbon must have 4 bonds. 1 there and there, and 1 there and there. Good. And that's correct. The next one is propene. Prop is 3. So you put them in like that. I'm going to put the double bond there. Would you prefer the double bond there? That's okay. It's the same molecule the other way around. Okay, so like just accept that. Now they must all have 4 bonds. That's the ground rule. So that has 2 bonds, that has 1 bond, and that has 3 bonds. Okay, you make it up as you go along now. Please stop learning these. you actually develop it and you get very, very good. The next one is butene. Butene, right? I'm going to write it for you. 1, 2, 3, 4. And the double bond, I'll put it in there just to keep it there, okay? It could be anywhere now. The butene could be anywhere. I'm just putting it there, okay? Check every carbon has 4 bonds. That is 2, so it needs 2 more. That has 3, it only needs 1 more. 2, 1 is 3, and 1 is 4. That is 2, it needs 2 more. That is 1, it needs 3 more. Very good. Don't forget you must put in your hydrogens. Okay, and that's butene, and you have the idea with that. Now there's an issue with this, of course, that the double bond could technically be anywhere. So let me draw a second one there for you now. That's 4 carbons. I'm putting the double bond here this time. That's fine, as long as I obey the rules, okay? That has 1 carbon, it needs 3. That has 3 carbons, 2 and 1, that has 3 bonds already, it needs 1 more. That has 3, it needs 1 more. And that has 1, it needs 3 more, and that's right. Now those 2 molecules are almost the same. They're not quite, but they're almost the same. Let me put in my hydrogens. H, there, and that's 1, okay? And that's butene. And this one again now, you have a H here, you have a H here, a H here. My writing is terrible. A H here, a H there, a H there. No, silly. 1, 2, 3, 4, very good. A H here, a H here, a H here, and a H here. Okay, good. Now be careful, be careful. It's easy to make mistakes here. Now they're both butene. They both have 4 carbons. And they both have a double bond. So how do they differ? We call that one But-1-ene. And we call this one But-2-ene. In other words, you break the name up into 2, and the number tells you the location of the double bond. That is after the first carbon. That is after the second carbon. Now I'm getting a bit technical with you, and I don't like that now because this won't get enough time. I'm only giving you enough to complete the sections we have to complete for this year, so you'll develop that a lot more in subsequent classes, I know that. But I'm just saying that to you, they're actually called isomers of each other now. They're very like each other, but they're structurally different. You see, they have a different structure, but they have exactly the same molecular formula. Each of them now has 4 carbons, and count them, and 8, what am I saying, and 8 hydrogens. Both of them have that. Okay, both of them have the same. That's but-1-ene and that's but-2-ene. Their chemical properties almost the same. Almost the same. They wouldn't be a whole lot different at all. But I'm just trying to deal with names for you for the moment. Going back here for a moment then, that's methane, ethane, propane, and butane. Don't forget the H's must go in when you're dealing with that. That's very, very important, okay? And lastly there, just a quick look at alkynes. Okay, I'm going to scrap the top lot now for a moment. And we put alkynes in here. These are alkenes. I better put in that name. Alkenes, E-N-E-S. I tend to use block capitals here because my writing is bad. Will you be careful in the exam? Please, the examiner will show you no mercy if there's an ambiguity in that letter. That letter is very important. Okay, now we're going to look at alkynes. A-L-K-Y-N-E-S, alkynes. And it has to have a triple bond. And the first member is ethyne. Okay, there you go, 2 carbons. Put the triple bond in there, and remember the golden rule. Every carbon must have 4 bonds, so there's 1 there. Okay, every carbon must have 4 bonds, so there's 1 there, and that's ethyne. Okay, good. The next one is propyne. So you have 3 carbons, 1, 2, 3. And you have to have 1 triple bond there, and make sure every carbon has 4 bonds. That one needs 1 more bond to get 4. That one, be careful, has 4 already. It doesn't need any more. And that one there has 1, it needs 3 more. And that's propyne. And I'll do butane finally for you. 1, 2, 3, 4. Triple bond here. Good. And every carbon must have 4 bonds. This needs 1. This doesn't need any, this needs 2, and this needs 3. And don't forget to put in your hydrogens. Now, it's the order in which you do things that makes you good at this subject. Okay, not the answer. Okay, that you would do that first, and you put in the hydrogens. And if you do it that way, you'll never get it wrong. That's very important. So they're the alkynes, okay? And again, they'd be classified as unsaturated now because they're not all single bonds. But I'll get to that separately. We'll do that on a separate occasion. And of course, the double bond, triple bond could be in different positions. Let me do a second one for you there. 1, 2, 3, 4. And we put the triple bond here. Okay, now that needs 4 bonds, you need 3 more. That does not need any more bonds, it has 4. That has 4, and that needs 3. Very good. So they're 2 separate molecules. Okay, I put in the H's for you. H there, there. And that's known as butyne, but it's but1-ine, Y-N-E. And this is but, B-U-T. Put in the H's for you. It's but2-ine, Y-N-E. So 2 tells you, the number tells you where the double bond is. That's in front of the first carbon. That's in front of the second carbon. Okay, very important that you're doing it like that. Now, they're isomers again, I've told you, and that's another day's work. We won't go there. But1-ine and but2-ine. Okay, that molecule, by the way, is the same as that one there. If you take any molecule and you turn it around, you may well just be talking about the same molecule. Be careful. Okay, so you have to be careful sometimes with molecules that you're naming it correctly, and that's very good. Now, that's that part of that I wanted to deal with before I go any further, and I think we've enough done on that. Let me just show you a list of alkanes then, just in terms of the way you might want to look at them. Can you see how they build up there for you? Can you see how they build up there? Methane is CH4, then you have ethane, all single bonds, then you have propane, then you have butane, then you have pentane. Now, I've gone a bit further. I've told you the first 4 are very important, right, that you're aware of that. Now, and you can see right down there, you have hexane and heptane and octane. Now, I've told you the first 4 are very important for you in the exams. Make sure you know them. Now, before I go any further, these are alkanes, and they are classified as being saturated. What that means is that all their bonds are used up. And consequently, if they're to undergo a reaction, they'll have to take out a hydrogen and put something else in instead of it. And that's hard enough to do. So will you take it, please, like that? That's the idea, that they're all saturated. All bonds are occupied. In the case of the alkenes and the alkynes here, you will see very quickly that because there's a double bond or a triple bond, that they could break open and things could just add into them. So they undergo addition reactions where you can add on to the double bond and break it, or add on to the triple bond and break it. But because there's no double or triple bonds here, the only type of reaction it can undergo is the substitution reaction. And that effectively means that there's far less reactions for this. There's another observation there then from the screen, if I can bring to your attention for a moment. Can you see I have the boiling points listed for you? I have them listed down the right hand side of that. Now, don't worry on Julie, I mean, all this is only just an illustration at the moment of what you would need, so be careful. They're the boiling points. The boiling point, you will see, is rising as the molecule gets heavier. And I think that's logical. I think you'd expect that. The heavier molecules, you'll find it harder to gasify them, to get them to take off, to turn into a gas. And that's very important that you be aware of that when you're looking through this. And that's exactly what happens. That as the molecule gets heavier, the boiling point goes up. It's very low there at minus 162. And down the other end there, you can see, look, you have boiling points of 120. Okay, that'd be important that you be aware of that now. That's very good, and that's what we're trying to work with as we go through this. Now, the stereochemistry of this and the shapes of them is for another time. I won't go there with that just now, but I do need you to recognize that we have to name the compounds. And again, I don't particularly want you taking these down. When I get to your notes, I'm going to slow down. When I get to your notes, specifically hydrocarbons, I'm going to slow down. But here are some rules that I just want you to see. Sorry, now I just want to make sure that I can put that on the screen for you, but you don't need to worry on Julie about this now. That I just need to make sure that you are seeing that okay for the moment in terms of what I'm going to do, right? Just take a look at this now and see how it is. You identify the longest chain in any molecule they give you, and that will be the parent. So if there was 4 carbons, it would be but. You know that'll be the parent name. You identify anything that's substituted into it then, okay, the substituents, and you arrange them in alphabetical order. Like if you had a chlorine there to be chloro, and if you had a bromine it would be bromo. So the B would come before the C in the name, that's all. Now you'll be doing this at a later stage, this is not crucial at the moment. The number of carbons, the number of carbon atoms, consecutively, you number them consecutively from one side or the other. In other words, you start saying that's number 1, that's number 2, that's number 3, that's number 4, or that could be 1, 2, 3, 4. You always number from the side, which will keep the number smallest, okay? You give the lowest number in the name, and that's what we have there, you see. That's but1ene that you have there, so there'll be no problem with that, okay? Use a number to indicate the position of every substituent, and where there is more than one of the same substituents, you use di or tri in the names, and that's ultimately what you're after for that. Now, you don't need to worry too much about that at the moment, because we're dealing with a very specific part of organic chemistry, and I just need to make sure that you'll be on top of this, okay? So here we're going now. I'm going to stay with your notes now, please, and as far as that is possible, you're on the first page of your notes, and I'd like you all to be focused on that. I told you already now, if you don't have these notes, will you please pause the video and go and print them, okay, because you need them. All right, very good. Now, we're dealing with hydrocarbons specifically here, okay, hydrocarbons, okay. And I've written in your notes here, these are compounds containing carbon and hydrogen only. Okay, carbon and hydrogen only. Many hydrocarbons are used as fuels as their heats of combustion is high. And that's right, we'll mention them in a moment, just in what we would actually be doing. So the first category here happens to be the alkanes, right? And this series has the general formula, and you'll have to write this into your notes. I've left it blank. You'll have to write it into your notes. CnH2n plus 2. Now please, that's missing from your notes. Write it in. Okay, this series has the general formula CnH2n. So look, if someone gave you this C20H42, now please don't get palpitations over this now, but I'm saying they might ask you what family does it belong to? Not name it, that wouldn't be fair. Okay, what family? CnH2n plus 2, you'd say, oh, that's an alkane. Okay, because of that formula. Now take a look at it, you see the ones we have. CH4. N is 1, 2 1s are 2, and 2 is 4. C2H6. N is 2, 2 2s are 4, and 2 is 6. C3H8. 3 2s are 6, and 2 is 8. Are you okay? So the alkanes have that general form. That's very useful now, because you'll always recognize them. Okay, and very, very important that you'd be aware of that. It's a great indicator that you have an alkane. Okay, these are saturated hydrocarbons and can only undergo substitution reactions, meaning you have to take something out to put something in because all the bonds are used up. Okay, that's it. And the first members are methane, ethane, propane, and butane. Alkanes in general are quite unreactive. Now, folks, that's okay. Let me put in butane here as well. C4H10. Cn, 2 4s are 8 and 2 is 10. Okay, so that's methane, ethane, propane, and butane. All right, and they're the names. And if they had to undergo a reaction now, they'd have no way of undergoing reaction without kicking something out, without substituting something, and that's exactly what they'd want. Okay, they're very unreactive because of that, because it's hard to break bonds and make bonds. Okay, and they're not as reactive. The word, okay, I'm just mentioning this and passing to you, they're unreactive. They used to be known in the good old days as paraffins. And paraffins come from two Latin words, parum and affinitum, meaning a little reaction for a lot of heat. A little and a lot. You'd have to heat the hell out of them and they hardly react at all. Okay, the only thing they're ever used for is burning or fuels, and that's important. Okay, they're quite unreactive. Chemical reactions. We are taking methane as a representative of this homologous series. We're taking that guy as representative of it, and I've written these two formula for you. The two reactions you want now is combustion. Combustion is burning, okay? So when you burn anything, CH4, you react with the oxygen of the air. Now, burn any organic compound and you always get carbon dioxide and water. I'll say that again. When you burn an organic compound, you always get carbon dioxide and water for leaving cert anyway. You can rely on that rule, I can assure you. Okay? And so you're going to get carbon dioxide and water. Now, are you okay with that? I've burned the methane. I got carbon dioxide and water. Now you must balance the equation, of course, and most of them are balanced easily by inspection. One carbon, okay? 4 hydrogens, 2 hydrogens here, so let's put a 2 in there. And lastly, the oxygens, 2 oxygens here, 2 oxygens here is 4. There's only 2 here, so let's put a 2 in there, and there's the combustion of that. Now, I'd much prefer to think that you could do what I did there and work it out, rather than trying to memorize that. Okay, you put down the organic compound here, put oxygen here, put carbon dioxide and water there, and to report it. Let me do this for ethane for you now. Let me go to propane for it, okay? C3H8 plus O2. We know it always gives carbon dioxide and it always gives water, and you're asked to balance that. Now, how are you fixed? Do you think you can deal with that? Are you okay? I'm going to start balancing then. 3 carbons, put a 3 in there. I'm working left to right now. 8 hydrogens, I've only 2 there, that's 8. And finally the oxygens, 3 2s are 6, 6 and 4 is 10, so I need a 5 in there. Okay, now that's very easy if you have a method. Now it is the method that matters, nothing else but the method. And please take care of that you get it right more than anything else. Okay, good. Now I've asked you to correct something in your notes already. Will you be careful, please? I asked you to correct that in your notes. I hope you've done that. Okay, it's up there in the title anyway, but the general formula is CnH2n plus 2 if it's an alkane, right? The second reaction then, the first one was combustion, the second one is chlorination. Methane reacts with chlorine gas in the presence of ultraviolet light. Now that'll be very important in your further study of this subject, okay? But I'm just giving it to you for the moment, okay? CH4 there, and it reacts with chlorine gas, okay? Reacts with chlorine plus Cl2. Now look what happens here. It forms CH3Cl. In other words, you have to kick out one of the hydrogens to get, because all the bonds are filled already, and you're going to get HCl there, hydrogen chloride. Okay, you're going to get hydrogen chloride there. That's missing from your notes, everybody. That's missing from your notes. Will you write it in? Okay, that's deliberate, by the way. I leave things out of my notes so that the class will have to react with it. Okay, good. Methane, chlorine, chloromethane and hydrogen chloride as a product. Okay, and I've said there, this is a substitution reaction. It is now. Don't take this down, but there you are. One of the hydrogens is substituted for a chlorine. That's difficult to do, so these are not very reactive. You have to break a bond and chuck something out and put something else in instead of it. That's not so easy. Okay, and we need to realize there's very limited reactions in this case. Now I've said down there, see mechanism later. Okay, later in your course you have to do a mechanism. You have to justify this with evidence supporting it. And that's quite an important piece of work, but it's not for us this year, and you won't be doing it right now. But there is a very important substitution mechanism there that you have to deal with at a later stage, all right? And that's that part now for you. Now at the bottom, I'm going to leave that for the moment then. This is a substitution reaction, see mechanism later. And you're asked to draw the structural formula of 2 things there. Now I'm being very smart with you, but I'm going to do that anyway. I'm not being fair to you here now, but I'm just trying to show you the extent of the subject before we get into specifics. 3-ethyl 2,4-dimethyl hexane. Okay, I'll write it down. 3-ethyl, T-H-Y-L, ethyl. Okay, 2,4-dimethyl hexane, H-E-X-A-N-E. Now folks, what is that? That's a hexane molecule with a number of things added into it. And I'm being very unfair to you here with this now. That's not fair. I've just put it in there based on the fact you have a lot of names done already. I haven't them done with you, so that will be it. There's the hexane. There's hexane for you. That's hexane. Okay. You have an ethyl group at number 3. That's number 1. Okay, number 1, number 2, number 3, number 4, number 5, number 6. Okay, so we have an ethyl group here, that's going to be C2H5. Now take my word for that, that's the ethyl group there. And you've dimethyl, meaning 2 methyl groups at 2. There's a methyl group here, CH3 at number 2, and there's a methyl group at number 4, CH3 as well at number 4, and you put in all the rest of the H's and you have that. Okay, and I'm just reminding you of the other thing in your notes as well, cyclohexane. Now these are horror stories, these examples. They should only be there after you have all the naming system done. And I haven't been doing that with you, so will you accept please that there would be some issues there. Cyclohexane, there's hexane, there's hexane. If you made a ring of that, knock out this hydrogen, you'd end up with a carbon chain like that. Okay, and you'd have 2 hydrogens on each of them. Okay, you literally would join that like that. Literally take the long chain and join them like that, okay? You'd have to kick out the hydrogen here, and you'd have to kick out the hydrogen here, of course, to do that. And therefore, that's a very special molecule. Why did I put it there at all? Because it's going to come up in fuels. Cyclohexane comes up in fuels, and I'll mention it there to you, that's all. Now, I'm not being fair to you, and in your defense, I must say to you, that's a horror story. You don't start here, you finish here, okay? You need to go back and do all the naming systems. We haven't them done. I'm not doing them right now. It's for another day, okay? I'm just saying that too, okay? You've dabbled in a bit of it, but that's all, and I'm aware of that. So that's alkanes for the moment. Maybe I should give you a simpler example of alkanes so that you're able to deal with it. Supposing I was to say to you now, draw the structure of 1,2,2 trichloro butane. Okay, draw the structure of that down. That's not too bad now, okay? You'll see where that's the parent, always at the back. That's the O'Hara part of the name, right? That's your family name. There, you draw that immediately. There's butane for you. That's butane. Trichloro means 3 chlorines. And this tells you where they are. There's 1 on the first carbon, that's the first one, bring a number on that. There's 1 chlorine there, and there's 2 chlorines on the second carbon, 2, 2. Are you okay? If it was 1, 2, 3 trichloro, then that fellow would be here. Are you okay? And that's how it would be, right? So that's exactly it. You draw the parent first, and then you put, these are called substituents. They're substituted for the hydrogen, so they're called substituents. Now, you'll get better at that, I promise you. You don't do this in a single class and say you can now name everything. You need good rules and good orders for that, and it gets very, very easy when you get to that stage now. Well done, you're doing fine. Now, that's the little bit on alkanes that's in your notes, and I'm now going to move on to alkenes, okay? That's alkanes, and I'm now going to move on to alkenes. It says, this homologous series is characterized by the presence of a double bond. As unsaturated hydrocarbons, they undergo addition reactions, okay? And I suppose I need to be telling you here that the general formula is written in the formula above. It's CnH2n. Okay? That is the general formula for the alkenes. K-E-N-E-S. Now, folks, those 2 letters, don't compromise them. Very important that you can deal with them and that everything is okay there for you, that you can work your way through that, all right? That's most important, that you're actually working through it, all right? So that's alkenes, right? And we have listed the main ones here then, okay? C2H4, C3H6, C4H8, and C5H10 if you wanted to go on with that, okay? There, them. And that, of course, is ethene, that's propene, that's butene, and that's pentene if you wanted to go with that. And we take ethene, we take this one as representative of the series. And they show you now. These particular, they're unsaturated. I'm going to draw them for you. Okay, there you are. There's the 2 carbons, right? There's a double bond there. So you've there, 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 and there. Okay, now because you have a double bond, I'll put in the H's this time. H there, there. And then because you have a double bond, of course, it's much more reactive. If anything reacts with that now, it's going to break the spare bond. Simply going to break it open and add on to it. Okay, and that's exactly what happens when you start to do that. Okay, so the first thing there is combustion. I'll do that first. Combustion is burning C2H4. Okay, C2H4. Mind the writing now, please. Mine isn't a great example there. It must be legible. If there's any doubt, they won't give you the marks. Plus oxygen, and it goes to carbon dioxide and water. All organic compounds, when you burn them, will give you carbon dioxide and water. Okay, very important. Carbon dioxide and water, very good. Now balance that, 2 carbons there, a 2 in there. 4 hydrogens there, so put a 2 in there. Oxygens last, 2 2s are 4 and 2 is 6, so there's a 3 in there, very good. That's that one, okay, and that's it. Now the idea of an addition reaction is much more demanding, and we have to be careful with this. I'm taking you somewhere here with this now because this is the minimum you need to know, but you do need to know this, okay? Basically, an addition reaction. I'll write it twice for you. C2H4, and we're reacting anything you can react with it. I put in plus XY's in your notes. So what you're going to get there is you're going to get C2H4XY. Now that looks silly until I draw it for you. There you go. And look what will happen when you react it with the XY. It'll break the double bond. And the X and the Y will go in there. Now just for a moment please, and this is a very important aspect of chemistry, inspect your work. Now some people are very good at that. They have a sense of looking at it and disseminating the information without being told anything. If I asked you to inspect what's happening here now, I hope you'd tell me, oh yes, we started off with a hydrocarbon and it had a double bond in it. And the double bonds are weak because there's 4 electrons there, they repel each other. So they break very easily. So that splits open, just like 2 doors opening like that. It splits open and the X goes in one side and the Y goes in the other. Now that's called an addition reaction. In other words, that added on to that. And in an addition reaction, 2 molecules become 1. Okay, 2 molecules become 1. That's addition. Now that's easier than the one we had a while ago, which was substitution, where you had to drag something out and put something else in instead of it. That's more difficult to happen. So these are more reactive. The alkenes are more reactive than the alkanes, and that's very important. Now, can I get you to write, please, immediately after that molecule in your notes, C mechanism later. Will you write it, please? C mechanism later, because it's very important. You won't be doing it this year, but you will need to know it's there. C mechanism later. The mechanism for an addition reaction is very important. Now, I suppose I'm really asking you the question, could you repeat that for propene? Of course you could. To just mean there'd be an extra carbon on there, an extra carbon on here. You'd break the double bond, and the X would go in one side and the Y would go in the other. That's all you'd want. You see, the X went in one side, the Y went in the other. And that's all that you'd want with that. It's fine. Now, look where we're getting with this. This is very important. I want to follow it up. Next in your notes there, and I've it circled in your notes, is the preparation of ethene. And I've said C experiment. Will you write in there, please, next to C experiment? That's a mandatory experiment, right? And there's an expectation that you would be able to describe how to prepare ethene in the lab. And that's what we're going to do next, okay? That's what we're going to do next. So I'm asking you just, to kind of take it that that's the background to that, and that's what we're going to do immediately after this. All right? Good.